Hello everyone. My name is Ashish Srivastava and I'm currently enrolled in certification program in RTL2 GDS in physical design provided by Center for Excellence in Chip Design, NILS, Noida. In this particular lab session, I'll demonstrate the basic synthesis flow in Genus. So, I'm using here a 8-bit counter design for the same. The very first step is to initialize the path of the library. The second step is to initialize the path of my RTL code. The third step is to read the library. The fourth step is to read my counter.v file, which is my RTL file. The next step is to elaborate this design. In this particular step, we actually check the errors in our code, whether it is schematic or the syntax error. Now, as we can see, there are no errors in our code, so it will pass the step. Now, the next step is to read my constraint file. Now, I'm, sub- I'm setting some parameters. The next step, so before proceeding with the optimization of our design, I would like to report the gates in our design. So as we can see, there are total 42 number of gates involved in our design. Now, I also want to know the schematic of my design. So I'll use this command GUI show. So here we can see the schematic of our design. Now, going back to our optimization stage. First we have syn generic. It takes an elaborated and fully constrained design as input and synthesizes it into a netlist of generic gates by doing high-level RTL and optimization. Next, we have syn map. It maps a design from generic gates to a technology library. Next, we have syn opt. The synop takes a map design as input and incrementally optimizes timing, area, and power. Now I would like to check if my number of gates have been reduced or not. So as you can see, the number of gates are reduced after optimization. Now if I want to check if my schematic has been changed or not. So I'll just call this GUI show command and check the schematic. And hence you can see the schematic is also changed. So thank you. That's all for today's lab session.